In this video, I'm going to be talking about the M+1 peak in a mass spectrum, and I'm going to be explaining how to find it, what it represents, and what you should do with it. First of all, the M+1 peak is a peak that is 1 unit above the M+ peak, or the molecular ion peak. So in order to find the M+1 peak, you have to be able to find the M+ peak. Remember that the M+ peak is the peak on the right-hand side that has the highest abundance. So if we look on this spectrum, on the right-hand side, the peak with the highest abundance is this peak right here at 70. This is our M+ peak, and as a reminder, the M+ peak represents the molecular ion, and it also represents the molecular weight, or the molar mass, for the whole entire molecule. This peak, the M+ peak, represents an entire intact molecule, making it all the way through the mass spec. So if this peak represents the whole entire molecule making it through the mass spec, then what's going on with this little peak down here at 71, the peak that is 1 unit above the M+ peak? This is the peak that we label the M+1 peak because it is 1 unit above the M+ peak. It is a very small peak. Sometimes it's not even there at all, so it's either small or non-existent. And so what could this peak possibly represent? If the M+ peak represents the whole molecule, then what could be represented by 1 unit above? This peak is due to the presence of carbon-13 isotopes. Carbon-13 makes up about 1% of all of the carbon atoms in the universe, so most of our molecules will not have any carbon-13 in them at all. So most of our molecules will not even be showing up in this particular location on the mass spec. When we do get some peaks showing up here, it's a very small amount, which is why this number, or this particular peak, is small, or sometimes so small that it's non-existent. What should we do about the M+ peak? In general, you should just ignore it. It is possible for you to use the relative heights of the M+ and the M+1 peak to figure out the number of carbon atoms in a molecule, but there are other ways to determine the number of carbon atoms in the molecule that are a lot faster and a lot easier to do. So in general, I just suggest that you ignore the peak. And just keep in mind that it is due to the presence of carbon-13. It's not really anything that you need to analyze or pay much attention to.